preprocessing, click on data preprocessing. So here I am in my project 5, that is feature engineering. So click on this file so that we can open it in our Google Colab environment. So here I am in my project 5. So for project 5, I need to import NumPy and Pandas. So here I am importing NumPy as NP and Pandas as PD. So let's run this cell to import these files. Now it's time to generate features and label. So here I am going to create a very simple and very small data set having X and Y values. So I am going to use the function np.arrange, and I am passing two input range, that is 1 and 11. So we know that np.arrange will generate the values between 1 and 11, but it will not include 11. Let's run this cell to see the value of X. So we can see that we have X 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Similarly, we can generate the value of labels using the same np.arrange function, but this time the range is between 101 and 111. Let's run this cell and we can see that we have the labels associated with those features. And now we can reshape our X. Let's reshape. And let's see now what is the shape of X. So we can see that the values of X are same, but now it is in 2D and we have represented it into a column vector now. So this is the creation of the features and creation of the labels. So this is our X. Now in data engineering or feature engineering, what we are going to do. So basically, if you see in this data set, we have only one feature. If we want more feature, we can create more feature from this existing feature. So there are a lot of methods in order to create the additional feature from the existing feature. So in this particular project, we are going to perform feature engineering by creating polynomial feature. So one of the many methods is a polynomial feature. That is, we used polynomial features in order to perform the feature engineering. So how to do polynomial feature and how polynomial feature will help us to add additional features from the existing feature. So first of all, I have to import the polynomial features. So I will import the polynomial features from sklearn.preprocessing. Okay, after importing the polynomial features, I have to set the degree of the polynomial feature. It means how many additional polynomial features I need in addition to my existing feature. So let's start with the degree is equals to 1. So here I am instantiating the polynomial feature. Here I have imported the polynomial feature in this first line of code. Here I am instantiating the polynomial feature and I am passing the input parameter, that is degree is equals to 1, and I am calling it as polyfeat, that is polyfeature. And here I am fitting and transform my polyfeature function to my existing feature so that I get more features. So I am passing in the first step, I have passed the degree is equals to 1. So let's run this cell and see the existing or the additional feature. So we can see that we have the existing feature from 1 to 10. So this second column is our existing feature. And when we write degree is equals to 1, so there is one more column which has been appended at the start of our feature matrix, and all values are 1. So we can see that when we write degree is equals to 0, it appends a column of 1 at the start of our features. Okay, we will discuss this, how this 1 has appeared in that column. Let's convert it into degree 2. Okay, when we convert the polynomial features, degree is equals to 2, and we run this cell again and look at the features now. Okay, now it is very much explainable. Now we can see that the center column has our original feature values, that is from 1 to 10. Now the additional feature has now degree 2. So if you see, degree 2 means this feature is the square of this feature. So here the power of feature is 2. Here the power of feature is 1. And now you can see the importance of 1. Here the power of feature is 0. If we write 0 at the power of any base, we will get the 1. So basically the first column indicates that here the exponent or power of feature is 0. Here the power of each feature is 1, that is from 1, 2, 3, 4, 5. Therefore, all the features are in the original form. And here the power of feature is 2. This 4 is square of this 2. Similarly, this 9 is square of this 3, and every number in this third column is the square of the number in the second column. So degree equals to 2 is creating the additional feature, which is the square of the additional feature, and also the additional feature, one more additional feature, which has a power 0 on each feature value. So if I put 1 raised to power 0, I will get 1. Similarly, if I put 2 raised to power 0, I will get 1. So anything raised to power 0 is 1. So if I put 2 raised to power 1, I will get 2. If I put 3 raised to power 1, I will get 3. Similarly, if I put 3 raised to power 2 or I square the value of 3, I will get the value of 9. So here we have power 0 of the feature, power 1 of the feature, that is the exponent, and the power 2 on the feature. If I write degree is equals to 3, what is going to happen? So if I write degree is equals to 3 and now I want to see my feature, you can see that there is one more column has been added, and now this is power 3 of the feature. If you take square of 2, you will get 4. But if you take power 3, or basically if you take the cubic value of 2, you will get 8. Similarly, if you take the cube of 3, you will get 27. If you take the cube of 4, you will get 64. So this now fourth column is the cubic value of every sample which is present in the second column. So here we have a feature, here we have the squared feature, here we have the cubic value of the feature, and here we have a power 0 of each feature. So in this way, we can see that in the original form of the data, we had only one feature. But by creating the polynomial feature of degree 3, we have created the additional 3 features with the help of this polynomial feature. We use degree is equals to 3 inside the polynomial feature, and we get 3 additional features. If we write degree is equals to 4, 5, 6, we will get more and more column. So it depends upon our requirement that how much additional features we need for the particular data set. So in this lecture, we have learned how to create the additional features from the existing features with the help of polynomial feature. So the polynomial feature is not the only method of creating more features from the existing feature. It is one of the many methods. Now, this is my feature matrix. What I can do, I can split the data into a training and testing component. For this, I need to import train test split. Here I am splitting the data. I have seen this function now many times. You have seen this. Here the testing size is 0.2. Now this splitting and this standardization is just additional step for this project. The main objective of this project was how to create more feature from the existing feature. That is how to create feature engineering. And in this particular project, we create the additional features, or we perform the feature engineering using polynomial features. So the polynomial feature is not the only method of creating the feature, but it is one of the many methods. So here we have an X-train. If we want to see the, if we want to perform the standardization on the training and testing component, here are the lines of code now which you have seen this code many times. Here are the standardized version of our training component, and here is the standardized version of our testing component. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture.